Let us see the circuit implementation for the cyclic code. So this is a commonly asked question in university exam. So we are going to see this problem in such a way that we can solve it in a very short time. So the generator polynomial given is x cube plus x plus 1. So gx is x cube plus x plus 1. Then generate the cyclic code for the data 1010. So uh, first you have to draw the encoder diagram. So this is your encoder diagram. So generator polynomial is x cube plus x plus 1. So this is 3. So there are 3 flip-flops. Flip-flop 0, 1, 2. Then 3. Now we will see about these vertical lines. So it is x cube. So it has coefficient 1. So this line corresponds to coefficient of x cube. Now x square is not there. So this G2, that means this line is not there. X square line is not there. Then x coefficient is 1. So this line is there. Then 1 for 1, this line is there. I'm going to tell you in such a way that you will remember this. We will not go in the details of how this has come. There are many methods to explain this, but but what I feel is easy that I will tell you. So this line corresponds to coefficient of x cube. This line corresponds to coefficient of x square, that is 0, and this line corresponds to coefficient of x, that is 1. That's why this line appears, and this corresponds to 1. And now we know that for 7 comma 4 generator polynomial is x cube plus x plus 1, and another generator polynomial is x cube plus x square plus 1. So you will get the encoder diagram this way. You know that the encoder diagram will be fixed if the generator polynomial is this x cube plus x plus 1. So this is the encoder diagram. And how now after that here this line is appearing, so there is one mod 2 adder. This line is not there, so there is no mod 2 adder. This is there, so this is mod 2 adder is there. It's always there because x cube is always there in the generator polynomial of 7 comma 4 cyclic code. After that there is a feedback switch. Now here there are message bits. There are two switches, switch 1 and switch 2. When this switch, or sorry, there is one switch and two poles. So if the switch is at position 1, then message bits are appear at the output, as well as it will go into the circuit. So when the switch position is at 1, then message bits will circulate here for 4 cycles, because 4 message bits are there. They will circulate here, and they will as well appear at the output. After 4 cycles, the switch position will be at 2. At that time the parity bits are generated and they will be collected at the output. So this is the operation of the circuit. So this you can by heart also, because you know you are going to get the for 7 comma 4 generator, there are two generator polynomials. One is x cube plus x plus 1, and the encoder diagram is like this. Now after that these are the parity bits are nothing but the outputs of the flip-flops. What are the outputs of the flip-flops? That are the parity bits after the 7th clock cycle, because this circuit will operate for 7 clock cycles. For first 4 clock cycles message bits, and after that for 3 clock cycles parity bits are there. Now you have to remember this also. Flip-flop 0 output, you can see here. flip flop 0 output is flip flop 2, this past, flip flop 2 past, that means previous output of the flip flop 2 plus D input. And when the feedback switch is closed, for the message bits feedback switch is closed, and after that the feedback switch is open when all 4 bits are inserted in this circuit. So when the feedback switch is closed, then flip flop 0 output, this output will be this message bits, that is D, this D plus flip flop to past output. So that will appear here, then after that it will appear here. So flip flop 0 is flip flop to past plus D, and flip flop 1 is flip flop 1 is flip flop 0 past, that means flip flop 0 past here plus flip flop 0 present. So how flip flop 0 present? Uh, uh, because flip flop 0 present is nothing but D plus flip flop 2. This is nothing but in message bits D plus flip flop to past, flip flop to past. So this is flip flop 0 past, and this is nothing but flip flop to past plus D, that is nothing but flip flop 0 present. We can say it as a present also. Then flip flop 2 is flip flop 1 past. These are present inputs or present outputs. So I can say present outputs. Flip flop 0 present, flip flop 1 present, flip flop 2 present. So this is the encoder diagram. So you will get to know very well with this table. So you have to write here flip flop 0, flip flop 1, flip flop 2. Initially it is 0, 0, 0. Then D. Then D is given as 1010. So write down here 1010. It's very easy. You just see how the answer comes. So 000 here 1010. First what you have to do, you have to add this 0 plus 1, that is 1. Then 1, then these two, 1 plus 0 1. Then for this you have to take 0 here. Flip flop 2 is flip flop 1 past. Now we will see the equations. Flip flop 0 here, this one. Flip flop 0 present output is flip flop 2 past plus D, that is 0 plus 1. Then flip flop 1 is flip flop 0 past plus flip flop 0 present. So 0 plus 1, 1. And flip flop 2 is flip flop 1 output, that is 0. Similarly, now you have to do the same operation for this row. 0 plus 0, 0. 1 plus 0. So here. Now for this. So 0 plus 0, 0. 1 plus 0, 1. Then this one will appear here. Now for this row. 1 plus 1, 0. 0 plus 0, 0. Now this one will appear here. Then 1 plus 0, 1. 0 plus 1, 0 plus 1, 1. This 0 will appear here, 0. So you will get, when 1010 completes, you will get 110. 110. That is flip flop 2 is 0. So first it will take flip flop 2. First output will be flip flop 2. So 0, then 1, 1, 0, 1, 1. So this table is very easy. For example, once again we will see initially when there is no input, then flip flop 0, flip flop 1, flip flop 2 is 000. After that you have to take this 0 and data 1. So 0 plus 1, write here 1. Then 0 plus 1, write 1 here. Then this 0 will appear here. Now for this row, 0 plus data is 0. So 0 plus 0, 0. Then 1 plus 0, 1. Then this one will appear here. Then 1 plus 1, 0. Then 0 plus 0, this 0. Then this one will appear here. 1 plus 0, this 1 plus 0, 1. Then 0 plus 1, 1. Then this 0 will appear here. So we can how to show it. I have written it here. Still this 0, okay, this 1 plus 0, this 0 and this one will give you this one. Then this and this will give you this one, and this addition, and this also addition, and this will appear as it is here. Now this you have to implement for all the rows. You will get 1 1 0. So answer is 0 1 1.